Okay, physics acceleration problem. The table below includes data for a ball rolling down a hill. Fill in the missing data values in the table and determine the acceleration of the rolling ball. So, on the left-hand column we have our time, and we also have our speed over in the right-hand side in kilometers per hour. It's very important that we know, and we can also have a look, obviously, time here, we can sort of pretty much guess, and it's pretty accurate guess, I suppose, that the time is going up every 2 seconds. So for every 2 seconds, the time is going up. So as time goes by, we are reading every 2 seconds. So if we fill this in, I think it's pretty safe to say that the next one is 4, next one is 6. So every 2 seconds, we take a reading. At the start, obviously, at time 0, it is not moving, but as it rolls down the hill, it goes 3 kilometers per hour after 2 seconds, 6, 9. If we follow this sort of number pattern, we can sort of guess that if it's for every 2 seconds that goes by, it goes faster 3 kilometers per hour. We can sort of have a look at the graph and make a pretty good inference at that. However, we need to, another question would be this, and I believe in the sheet that I actually handed out for my students, the question would be, what's the acceleration? What is the acceleration for this ball over that period of time? So using our graph, we need to bring out some essential bits of data. First things first, we want to find out acceleration, okay, obviously, which is going to be its final velocity, take away its initial velocity, so it's change in velocity over a certain period of time. Now we can actually pull out bits of data from the table in order to plug in into our calculations here. First off, maybe if from starting to finish, so that our final value was 10 seconds. So what if we made our time over 10 seconds? How fast was it going at the start? We know that at the start it was going 0. Now here is the important thing for now. It was going 0 kilometers per hour. Now we know that as 0 meters per second, but now we need to be able to actually convert it. At the end it was going final velocity of 15 kilometers per hour. Now we need to convert that into meters per second. Now we know that for every kilometer, because there's 15 kilometers, there is 1,000 meters. So 15 kilometers is 15,000 meters, and that's over 1 hour. We know that for every minute, so 1 minute is 60 seconds, and for 1 hour is 60 minutes. So to get 1 hour equals 60 seconds over 60 minutes. So in 1 hour there are 3,600 seconds. So if we come up here, over that 15,000 meters, it would cover 15,000 meters over 3,600 seconds. Now there's going to be this really beautiful magic number that I've already taught some of my students, because we can actually eliminate some numbers here, some zeros. So if we eliminate that 0 and that 0 and that 0 and that 0, but if we put a decimal point here, then we can eliminate that 0. So in the end, to convert kilometers per hour to meters per second, see here, meters per second, we divide by 3.6. So 15 kilometers per hour into meters per second is actually about 4.1. So let me get yellow, is actually, let me actually get a little bit of space from here. Final velocity 15 kilometers per hour is 15 over 3.6, which is approximately 4.17 meters per second. So now we have our final velocity, we have our initial velocity, we have our time, we can find out the acceleration. So acceleration equals Vf minus Vi over t, which equals 4.17 meters per second. Take away 0 meters per second, we don't need a calculator for that, over 10 seconds, so the final acceleration should be 0.42 meters per second. So that's our final acceleration there. Final acceleration being 0.42 meters per second. Taking away from this particular, we can't see that, so taking away from this particular table at the start, time 0, it was 0 kilometers per hour. At the end, 15 kilometers per hour over 10 seconds, so we found out the acceleration being 0.42 meters per second.